Hello students, today we discuss about the correlation. Correlation means the related variation among two variables. For example, if I write here x and y variable, so whatever the relation between these two variables, whether it is increasing or decreasing, otherwise both are increasing or both are decreasing, okay, such type of relations will be studied, and this method is known as a correlation. Correlation is nothing but the related variation among two variables. So for example, we'll take here the height and weight. Okay, in general we observe that those who have greater height, they have greater weight, and those who have lesser height, they're having lesser weight. Okay, here we are studying about the relation between height and weight. It is okay. Similarly, we can discuss the many more examples, like the next example is advertisement and sales. What is the relation between these two? Next is demand of product and price. Okay, so the correlation is defined like this. Correlation is technique of finding the relation between the two dependent variables and set of data. It is also be defined as the related variation among the two dependent variables. So next is, in correlation there are four types. The first one is positive correlation, second one is negative correlation, third one is non-correlation, and fourth one is perfect correlation. We'll discuss one by one here. The first one is positive correlation. So positive correlation, for example, if I take here income and expenditure, so we observe that if income is goes on increasing, that means your expenditure also be goes on increases. If income is goes on decreasing, then your expenditure also be goes on decreases. It means the variation of the two variables which will be observed like this. How? If the variable varies in the same direction, that means if one variable increases, the other variable also be increases in the same direction. Otherwise, if one variable decreases, other also be decreases in the same direction. Such type of variation is known as positive correlation. Understand? So it will be defined like this. Correlation is positive if the variations in the two dependent variables varies in the same direction. That is, increase of one quantity indicates the increase of other quantity in the same direction. Similarly, decrease of one quantity indicates the decrease of other quantity in the same direction. The meaning is here the variation of the variables which variables will be observed in the same direction. The variation will be observed in the same direction. Move to the next one, that is negative correlation. Let us take one example here, that is production of vegetable and price. If production of vegetables is goes on increasing, then price will be automatically goes on decreases. If production of vegetable is goes on decreasing, then price will be automatically goes on increases. Here the variation of the two variables which will be observed like this. How? One variable increases, other will be goes on decreases. Otherwise, one variable decreases, other will be goes on increases. Here the variation which will be observed in the opposite direction. This is not only about the vegetable. If you take any product, if it is the production is increases, the price will be automatically goes on decreases. Otherwise, if the production decreases, then price will be automatically goes on increases. So this type of variation which will be observed in the opposite direction is known as negative correlation. Getting? So it is defined like this. Correlation is negative if the variation in the two dependent variables varies in the opposite direction. That is, when one variable increases, then the other variable decreases in the opposite direction. Similarly, when one variable decreases, then the other variable increases in the opposite direction. So next one is non-correlation. Let us take one simple example. Temperature and price of the gold. If temperature increases or decreases, price of the gold cannot be increased or cannot be decreased. There is no relation between temperature and price. These two variables are not having any relation. So such type of relations which not show increasing or decreasing proportion, then we can say that it is non-correlation. So it is defined like this. If the two variables are independent and the variation does not show direct proportion or inverse proportion, such type of relation between the variables are known as non-correlation. This is also known as zero correlation. So next is perfect correlation. It is defined like this. If the variation in the two dependent variables varies in the linearly in such a way that it may be positive or negative. The meaning is, suppose if I by using the different measurements like Carl Pearson's coefficient of correlation method, otherwise the Spearman's coefficient of correlation method, if I get here +1, then we can say that it is perfect positive correlation. Suppose if I get here -1, then you can say that perfect negative correlation. Understood? Measurements of correlation. The first one is scatter diagram or dot diagram. Second one is Carl Pearson's coefficient of correlation. This is also known as product moment method. And third one is Spearman's coefficient of rank correlation method. Let us discuss the first one, that is scatter diagram. Scatter diagram is nothing but the variables x and y which will be plotted on a graph by using x and y plane is known as a scatter diagram. So let us discuss the definition. Scatter diagram is a graphical presentation of bivariate data. The two variables x and y are taken along the x and y axis, and every pair of values in the data is represented by a point on the graph. Next is types of scatter diagram. The first one is perfect positive correlation. If you plotted a graph and all the points which will be on the straight line and which shows the upward slope, then we can say that it is perfect positive correlation. That means R equal to be +1. So second type is perfect negative correlation. If you plotted the graph, if all the points which will be on the straight line but shows a decreasing slope, then we can say that it is perfect negative correlation where R equal to be -1. Third one is positive correlation. If you plotted the graph by referring the x and y variables, if all the points shows a increasing slope but not on the straight line, then we can say that it is a positive correlation. Here you have to understand the difference between what is the positive correlation and perfect positive correlation. Perfect positive correlation means if I plotted the graph, if all the points which will be on the straight line and shows the increasing slope, then we can say that it is perfect positive correlation. If all the points shows the increasing slope but not on the straight line but clustered around the line of increasing slope, then we can say that it is a positive correlation. Next is negative correlation. If I plotted the graph by referring the x and y variables, if all the points shows a decreasing slope but not on the straight line, then we can say that it is a negative correlation. So here also you have to understand the difference between perfect negative correlation as well as negative correlation. So perfect negative correlation, that means all the points shows the decreasing slope, but on the straight line it is like it is. But here the points shows the decreasing slope but not on the straight line. Getting? So this is called as negative correlation. Understand the difference? Okay. Move to the next one. Non-correlation. If I plotted the graph by referring the x and y variables, if all the points cluster around the graph and not showing any direction, whether it is increasing slope, otherwise it may be decreasing slope, then we can say that it is non-correlation. Getting? Now discuss the examples. The example number 1, plot scatter diagram from following data. So here the data is given like this. For x variable 11, 12, 13, 14, 15, 16, 17 and 18. For y variable it is 14, 18, 20, 18, 24, 22, 23 and 26. If you want to plot a scatter diagram, first you have to plot x-axis and y-axis. On the x-axis you have to take the x variable and on the y-axis you have to take the y variable. Before dividing the x-axis and y-axis, you have to verify which is the highest value in x variable and y variable. Here 18 is the highest value and in the y variable 26 is the highest value. It means axis will be divided in 18 equal parts, whereas y-axis which will be divided in 26 equal parts. So now you have to verify which is the lowest value here. In x variable it is 11 and in the y variable it is 14. Getting? So now I will divide the x-axis. So make the first division and write down the lowest value, that is 11. Okay, see here I plotted two parallel lines. This indicates the false base. So whatever the values in between 0 to 11 which will comes under this false base. Now move to the next division. Getting? So next, maintain some distance, take it 1 centimeter or 2 centimeter and make the division and write down the next value, that is 12. So similarly 13, 14, 15, 16, 17, 18. Like this you have to make the divisions on the x-axis. Now you have to move for the y-axis. So in the y-axis the lowest value is 14. Apply the same procedure, whatever procedure applied on the x-axis. So make the division here. You have to write 14. Okay. Next, maintain the sum distance. Take it 1 centimeter or 2 centimeter and make the next division and write down as 16. Next it is 18. Next it is 20. Next is 22. Then 24, 26 and 28. Like this you have to make the divisions. Once you made the division, now you have to put the points. How to put the points? By referring the x and y variable. So move to the first one. First one is 11 and it is 14. Getting? So on the x-axis you have to take the 11 and y-axis you have to take the 14. Wherever the points coincide, you have to put the point now. So now I am putting the point. For 11 on the x-axis and the y-axis it is 14, the first point. Next, similarly you have to put the point for next one, that is 12, 18. Next it is 13, 20, 14, 18. Next 15, 24, 26, 22, 17, 23 and 18, 26. Like this you have to put the point. Now you have to verify this one. Here it shows the increasing slope. Getting? It shows the increasing slope, but the points are not on the straight line. If I plot the line at the center, all the points are not on the straight line, but it is clustered around the straight line and shows the increasing slope. So our conclusion must be it is a positive correlation between x and y variable. This is nothing but a positive correlation between x and y variable. Getting?